Hi, second year students. The journey in the field of integration continued. Our exercise 3.7. It's part number 3. Questions from 14 to 17. I have written for you how to evaluate definite integral concerning trigonometric functions, Napierian log, exponential function, and the wonderful question 17, 1 over 1 minus sin x, a really good question to solve. Without wasting time, just start our question number 14. Reads our limits runs as minus pi to positive pi over 2. I call them symmetrical limits cos square x dx. To integrate trigonometric functions, we have different strategy for sine and cos when they have even power and the odd power. For odd powers, we utilize the identities sin square x is equal to 1 minus cos square x and cos square x is equal to 1 minus sin square x. Whenever the power of sine and cos are odd, when they have even powers, they have different strategy. I am talking about only sine and cos, not for the remaining trigonometric functions. And when they are even, cos square x is given by 1 plus cos 2x, doubling the angle dividing by 2, and sine square only differs in sign, that is 1 minus cos 2x over 2. These are the identities when sine and cos collectively have even powers, they have odd powers. They have odd powers. Don't confuse yourself. It is sine square, it's also sine square and cos square. It's okay. But at the start, look at this. Power is even. We jumped over, we utilized such type of identities. At the start, at the outset, the power is even. We have to utilize these identities for sine and cos. Individually or collectively, they have even powers. If they have odd powers, then we have to apply these identities when we have data of such type sine 5x or might be cos cube x. Look at this. That is the difference. At the outset, powers are odd. Refer to these identities. They help. They are helpful for you. If the power is even, that is the strategy. That is the strategy. Only sine and cos have different strategies for even and odd powers. The rest functions have a single strategy. Simple trigonometric identities: 1 plus tan square is equal to sec square, 1 plus cot square is equal to cosec square, to be utilized to integrate. There is no difference of the strategy when the rest four functions tan, cot, sec, cosec have even or odd powers. For sine and cos, even and odd powers handled differently. That is the approach for odd powers, and that is the strategy approach for even powers. Look at this. At the outset, at the start, we have even power. We refer to this identity minus pi over pi, or symmetrical limits minus pi to pi. Cos square means 1 plus cos doubling the angle dividing by 2 dx. Alright, 1 over 2 as a constant outside and integrate 1 dx plus cos 2x dx. It's a simple integration, as just ask yourself, one the differentiation of x and cos the differentiation of sine, and we are done. Just integral operator is distributable. Way it is distributive, I have distributed minus pi to pi limits 1 dx as well as cos 2x dx. Let me write the limits like a child for you to give you clarity. Minus pi to pi over 2. Integration. When your brain is 100% shut or totally shut down in case of integration, just ask yourself, what is differentiation of which function x? And cos is differentiation of sine 2x. Don't forget to divide with the differentiation of the angle. Look at this. Angle is a multiple of 2. Angle is a multiple of 2. Angle is a multiple of 2. And differentiation of 2x is 2. Differentiation of 2x is 2. Dividing by 2. Let's see. It's our answer. In case of indefinite integral, as we have limits, so don't forget to apply limits. That is upper limit minus lower limit. Upper limit minus lower limit. Okay, writing 1 over 2 outside. First upper limit, instead of x pi over 2, it will become sine 2, x means pi over 2, 2 cancelled out, 2 cancelled out, overall divided by 2 plus c, that's my upper limit, lower limit minus pi over 2, that is plus, instead of sine 2, limit is minus pi over 2 and plus c. These two cancelled out. Here I have sine pi and here I have sine negative pi. Sine pi and pi. Check the values of sine 180 for me. Sine 180 is equal to what? Okay. Here, what remains? Let me write for you. 1 over 2. X we have done so. Applying it pi over 2. Here we are left with sine pi. Sine pi over 2 plus c minus 1 over 2. C is outside because 1 upon 2 doesn't multiply to 2. So c, if we multiply it's okay, but it's outside. Negative pi over 2 and I have left with minus. Here is positive sine negative pi and plus c and r plus c. What is the value of sine pi? Let me sort out. Sine 180. Sine 180 is equal to 0. Okay. Sine, it's sine pi divided by 2. Sine is only sine pi. Sine pi means 0. I have taken the assistance of a calculator. Plus c minus 1 over 2. We are left with minus pi over 2. It's also r0. Negative sine pi, if I write in that fashion, still sine is an odd function. Minus to be retained. Negative, positive, negative. Sine pi is 0 in the next step. And here, applying this minus multiply, constant will be cancelled out. I have 1 over 2 pi over 2. It's minus minus plus pi over 4. If you multiply this one, it's 0. It has been neutralized. I have pi over 4 plus pi over 4. As denominators are homogeneous, write one time, no change in the numerators. Pi plus pi, 2 pi over 4. Cancelling out, we are left with pi over 2 and it's our answer. Pi upon 2 is our answer in that case. Pi upon 2 is our answer in that case. When at the outset sine and cos are present, if they have odd powers, take the assistance, take the help of these two identities, sine square and cos square. Simple one. When at the outset, at the starting or in mix, both have even powers. Sine and cos have even powers. These are the two identities to be utilized to integrate such type of trigonometric functions. Okay, cool. Moving further, question number 15. That's integration ln x. It's the case of by parts because ln is not a differentiation of anything and ln has no identity. So utilizing by parts, we have done so. Eilert rule, inverse function, then logarithmic, then algebraic, then trigonometric, then exponential, and finally Eilert trigonometric and exponential is finally. Our question is 1 to 3. ln x dx. Our Eilert rule, inverse, we are familiar 100%. Inverse function or arc functions, inverse trigonometric, inverse hyperbolic functions, whatever the case. So, logarithmic functions, logarithmic functions, A, algebraic functions, T, trigonometric, and E, finally, exponential. Exponential functions. It is the strategy how to select the first one. If you have chosen the first one correct, the questions keeps on shrinking, and it keeps on reducing, and almost a good normal answer. If your strategy to select first is incorrect, then your question is going to be stuck, or it is going to expand infinitely. It is going to expanding on and on, not coming in the shape. Here it is ln x according to I rule. In Euler rule, there is no inverse, then logarithmic. It's our first one. Second function we can generate as 1. Second function we can generate as 1. That is the case. Now ln x, first same, integration of the second one, minus whole integral. Differentiation of the first, that's ln x. Integration of the second, owing to this presence of integral, here is the dx. Ln x same. Integration of 1 is x, negative. Differentiation of ln x is 1 over x, and integration of 1 is x dx. Cancelled out. They cannot be multiplied as they are two different functions. Ln x into x, it can't be written as ln x square. But keeping them as different functions, x ln x, it can be written x ln x, not ln x square, not ln x square, not ln x square, x ln x. Minus, here remains 1 dx. Integral prevails, again integrate 1 times. Ask yourself, one is differentiation of which function? It's x plus c. It's our answer. Just we have to put the limits now. Limits are 1 to 3. Limits are 1 to 3. I'm not writing. Okay, upper limit. Upper limit minus the lower limit. That's the way to put limit. It will become x means 3 ln 3 minus 3 plus c. It's our upper limit. Minus lower limit, instead of x, plug in 1 ln 1 minus 1 plus c. Opening this multiply, I have 3 ln 3 minus 3 plus c minus 1 ln 1 minus plus 1 minus c. C cancel out. 3 ln 3 minus 3 plus, okay, whatever remains, let me write in a good fashion for you, as I am running short of the frame. Cutting short my journey, coming back from the start of the board. That is, I have left with 3 ln 3 minus 3 minus 1 ln 1 plus 1. Minus 3 plus 1, it will become 2. 3 ln 3 minus 2. If you take the value of ln 1, it's going to be 0. As I think it's our answer, but one can utilize the property of log. Coefficient of the log can be converted to power. Ln 3 cube minus 2. 3 cube means ln 27 minus 2. It's our answer. Leave here or here. It's up to your understanding and requirement. Both answers are correct. Both answers are correct. This technique is helpful, especially in differential equations. Whenever you deal differential equations at lower or upper levels, such type of situation arises most often. Like differentiation is present in numerator and function is present in the denominator having power 1. So ln situation mostly props up. To utilize this identity, the 3 famous identities of log to be utilized to get the answer in the proper fashion. Okay, this exponential one, it's simple one. Question number 16. Limits runs 2 to 4. E raised x over 2 minus e raised x over 4 plus c. It's a simple one. It's a simple question. As integration of e power x is e power x. This integral operator is distributable. Is distributed to each term. 2 to 4 e raised x over 4 dx. Now have a look here. It will remain same. Don't forget to divide with the differentiation of power. Differentiation of power. Differentiation of power is differentiation of x over 2. It will become 1 over 2. It will become 1 over 2. And in that case, differentiation of x over 4 with respect to 4, it will become 1 over 4. Don't forget to divide with the differentiation of power. It will become 1 over 2 minus e raised x over 4 same and dividing by 1 over 4 plus c and putting limit. Division, another division, 2 comes here as well as 4 comes here. So our situation is to be 2 times e raised x over 2 minus 4 times e raised x over 4 plus c, putting limits, upper limit minus lower limit as usual. Upper limit minus lower limit. First adopt 2 to 4. Our limits are 2 to 4. First 4. 2 e raised 4 over 2 minus 4 e raised 4 over 4 plus c, that's my upper limit, minus 2 e raised, instead of x insert 2, lower limit, minus 4 e raised 2 over 4 plus c. We are left with here 2 to the 4 e square minus 4 only e plus c. It will become minus 2e, 2 divided by 2 is 1, minus plus, it will become 4 e raised 1 over 2. What's our lower limit in that case? E raised 1 over 4, 1 over 2. 2 on the 2, 2 to the 4, 1 over 4 minus c. C cancelled out. What we are left with? Only 2 e square minus 4e minus 2e. It will become minus 6e. This term will remain same, 4 e raised 1 over 2, 1 over 2, it's our answer. C has already been cancelled out. I can write instead of 1 upon 2 under root. This is our final answer. This is our final answer. Upper limit minus or lower limit 2 e raised square 4e plus c minus 2e. Good, good. We are cool. It's our answer. It's our answer. Final question, a good one. Such type of questions are present. 1 minus cos in the denominator, 1 minus sine, 1 plus sine, 1 minus sine. 1 minus sine or 1 plus sine. 1 minus cos or 1 plus cos. Such type of questions are present. Even for differentiation, for integrating, and even for solving trigonometric identities, proofs in trigonometric identities. Whenever such type of situation prevails, rationalization is the best strategy. Rationalize 1 minus sign, changing the major symbol. That's our major symbol, main symbol, converting this from negative to positive or positive to negative. In that case, from negative to positive. 0 to pi over 4. It will become 1 over 1 minus sine x, dividing and multiplying by 1 plus sine x, dividing and multiply by 1 plus sine x. Let me write, rationalize. Rule 0 to pi over 4, 1 times 1 plus sine x, as it is 1 plus sine x. Whenever you rationalize according to numerator or denominator, difference of two square situation always props up. Look at this, 1 minus sine, 1 plus sine. 1 minus sine, 1 plus sine. A minus b, a plus b. Difference of two square situation props up. It is tantamount 1 square minus sine square dx. 1 minus sine square is equal to cos square. We are familiar from this magic identity at the outside of the trigonometry at our 8th grade. Maybe at our metric, 1 minus sine square means cos square dx. Don't you worry. Dividing cos square with the each term, 4 to pi over 4, 1 divided by cos square separately, or sin x dividing by cos square x dx. We are familiar. Cos is a reciprocal of sec. Here is a square. Keep it. It will become sec square. Here sine over cos square x. It can be written as sine divided by cos times 1 over cos. Sine divided by cos times 1 over cos. Cos square can be written as cos times cos. Sine over cos, it's our famous identity tan, and it's equal to sec. It's tan, it's sec. It's tan, it's sec. It's tan, it's sec. Okay. Making a space for myself. we are left, we are arrived at 0 to pi over 4 sec square x plus sine over cos means tan, 1 over cos means sec. Look at this, we arrive at our comfort zone. Ask yourself, is it differentiation of something? Yes, it's differentiation of tan. It's differentiation of tan, so its integration is only tan. It's differentiation of sec. It's differentiation of sec. Differentiation of sec is tan x sec x, tan x sec x. It is differentiation of sec. It's differentiation of tan. Bingo. We arrive at our final result. 4 to pi over 4, as this linear operator is differentiable, multiplying with each term. 4 to pi over 4 tan x sec x dx. Ask yourself, sec square is a differentiation of tan, so integration of sec square is only tan. Integration of sec is sec as well as tan. Integration of sec is sec and tan. Integration of sec, oh sorry, differentiation of sec is sec and tan. Differentiation of sec is sec as well as tan. So its integration must be sec. Let's see, just come into play the limits. Sec square is the differentiation of sine, so its integration is tan. Tan x sec x is differentiation of sec. Tan x sec x is differentiation of sec. So integration of sec and tan is sec and tan is sec, only sec. That I have done. So upper limit minus lower limit. Tan upper limit is pi over 4 plus sec pi over 4 plus c minus tan lower limit is 0 sec 0 and plus c. Plus c. Tan 45, tan pi over 4 is equal to 1. Sec pi over 4 is only root 2 plus c minus tan 0 is 0 minus plus minus sec 0 is equal to 1 and negative c cancelled out. This 1 is also cancelled out. What we are left with? Root 2. We are left with root 2. Root 2 is our final answer in that case. Root 2 is our final answer in that case. It's my tiny effort for you to explain to you integration. Whenever you are 100% outclassed or knocked down by integration question, just settle down yourself, settle the dust and ask yourself, is it differentiation of something? Is it differentiation of something? You are going to arrive at somewhere, at some place. Or second option, ask yourself, is this function derivative situation? Function derivative situation. These two strategies are two simple ideas leads you in the field of integration to integrate further complicated questions. It's all by itself. Next.